All right, everybody, this is 4.2. Today we're going to be adding horizontal asymptotes to our repertoire. Okay, so last time we talked about vertical asymptotes and x and y intercepts and domain and excluded values or values of discontinuity. Okay, so today we're going to be adding horizontal asymptotes. These ones are not as cut and clear as the vertical asymptotes, but if we can come up with some sort of pattern, I think it will really help us so that we can find those easily. Okay, so what we're going to do is we are, before I get into that, just a reminder that horizontal asymptotes, those are also known as end behavior asymptotes, meaning as we go really far to the left or to the right, as like x goes to infinity or as x goes to negative infinity, the asymptote, it guides that graph. It gets closer and closer to that line, but it never crosses as it gets really far. But it can cross in the middle of your graph, okay? And we'll talk about when that happens and why, okay? But again, you can always cross the horizontal asymptote. It's only the vertical asymptote that you can't cross, okay? So let's get into this. We're going to try and kind of, there's some sort of pattern that has to do with the degree of the numerator and the degree of the denominator. So for these examples, if we look at these, we all have degrees of 1. So if we look at all of these x's, the highest exponent is 1. Okay, so the degree of the numerator and the denominator are 1 and 1. It could also be like 2 and 2, 3 and 3. So we're just trying to figure out what happens when they're the same degree. So if the degree of the top is the same as the degree of the bottom, then we're going to find something that's going to be helpful for us. Okay. So what we're going to do is to find more or less what the horizontal asymptote is. We're going to plug in a really large x value. So for here, we're going to maybe plug in 1,000 and see what we get. So if we plug in 1,000, we would get 2 times 1,000 over 4 times 1,000 plus 1. And that would end up giving us 2,000 over 4,001. And we could put that into our calculator, would end up getting, let me write it over here, 0.49999, okay, which is approximately 0.5, okay. So keep that in mind. Again, that's the same as 1/2. Let's try the next one and see what we get, and then we're going to compare and see if we can find how are these numbers showing up in the graph. So here, if we put in 1,000, maybe I'll do it below so we have more room. So y equals 7 times 1,000, so 7,000 plus 4 over 1,000 plus 1. So that would end up giving us 7,004 over 1,001. And if you put that into your calculator, you'd end up getting something like 6.997, which is approximately equal to 7. Okay? All right, and then our last example, if we plugged in 1,000, we'd get y equals -3 times 1,000 plus 1 over -1,000 plus 2. And if you type that into your calculator, just for sake of time, we'd end up getting 3.007. And that's approximately equal to 3. Okay, so can you see how we can come up with that horizontal asymptote? Okay, so we're going to come back to that, but we're going to write these down. So we'll say horizontal asymptotes, again, is a horizontal line. So it's y equals 1/2. This would be y equals 7. And y equals 3. So maybe you can see this already, but let's do our example 2 so that we can verify, okay? Well, no, let's just talk about it. Okay, so here you probably noticed that 2/4 is the same as 1/2. 7/1 is 7. And -3/-1 is a +3. So if they have the same degree, then we just look at the leading coefficients. Okay, so again, it's important to have it in standard form to be able to find that. Okay, so if it's in factored form, then we'd need to maybe do a little extra work to find those values. Okay, all right, so next here, let's look at the degree. So on the top we have a 1, on the bottom we have a 2. Here we have a 1 and a 3 for the numerator and denominator, and here we have a 2 and a 4 would be those degrees. Okay, so these are not all the same. Like up above, that was always 1 and 1, 1 and 1. Again, it would also be okay if it was 2 and 2 or 3 and 3, as long as they're the same degree. Okay, but these are not the same degree. So let's kind of see what happens here if we plug in big numbers. So here we could do y equals 1,000 minus 1 over 1,000 squared minus 2 times 1,000. Okay, and just to save a little time, we would end up getting 0.01, which is approximately equal to 0. Okay, let's try another one. So if we did y equals 2 times 1,000, so you won't need to do this unless you forget like kind of the pattern that we find come up here. But if you got stuck and forgot, you could always plug in like a large number and see what you get. Okay, so here we'd get what? 1,000 cubed, which is like 1,000,000. No, that's like 1,000,000,000. Okay, and then minus 8. So if we type this into the calculator, we would end up getting something like 0.000002. Again, that's approximately equal to 0. So again, these lines are y equals 0. Okay, without even doing the next time, or the next example, what do you think the horizontal asymptote would be? You're right, it would just be y equals 0. So if the numerator, the denominator, the degree of the numerator is smaller than the degree of the denominator, then the denominator takes over. Like 1,000 to the 4th, that's like 1,000,000,000,000. And for the top, it's only 1,000 squared, which is 1,000,000. So 1,000,000 divided by 1,000,000,000 is like really small, really close to 0. I think this one, in effect, if we plugged in 0 into that function, we would end up getting 0. Okay, so what do you notice between examples 1 and examples 2? Again, if the degree of the numerator is equal to the degree of the denominator, then we just look at the coefficients. The leading coefficients give the horizontal asymptote. Okay, if the degree of the numerator is less than the degree of the denominator, then it's always y equals 0. Okay, the bottom overcomes the top. It just gets way too big on the bottom, so it gets to 0. Okay, as x gets big. All right, so let's see if we can come up with these ones without plugging in stuff. So here we have the same degree, so then the horizontal asymptote would be y equals 12. If the degree of the bottom is bigger, then it's going to be y equals 0. And here the degree is the same, so it would be y equals -3. okay? All right, so here is just a summary of all the things we've covered so far. One of the things we did not cover and we won't be going over is called oblique or slant asymptotes. So that just happens when the degree of the numerator is bigger than the degree of the denominator. And then the graphs look a lot like, I don't know, if this was our x and y, it looks something like this. It's kind of crazy like that, okay? So that would be like a slant asymptote, okay? But we won't be going over that on your test. Okay, so these are all the things we've talked about. If you ever need, you can kind of refer to this. I think this is probably helpful. There's one more thing that we'll add to this next time, but from now, that's what we've got. So we've got these 3 examples, and that's all we have left, just to review all the things and then add that horizontal asymptote. So why don't we do the horizontal asymptotes first, since that's just what we're most familiar with. Okay, so if we look at this first one, again, these first 2 are not in standard form. So it might be helpful to write it in standard form. I'll just write that over here. It'd be y equals negative x plus 4 over x minus 2. So then we would say, oh, they have the same degree, and we're just looking at their leading coefficients. So this negative is just a negative 1, and the leading coefficient on the denominator is just 1. So the horizontal asymptote would be y equals negative 1. Okay, let's try B. Again, we'd probably want to get that to standard form. Okay, so again, when we do like binomials, you could use a box if you'd like. But really what we end up getting is x squared, and then we end up adding, well, I don't want to get into that, okay? But anyway, we'll end up getting, I guess maybe I should do that. We'll write it out. We'll write it over here. Okay, so we would have, I would first distribute that negative, so we'd end up getting negative x and negative 2, and then x and 5. And we would end up getting negative x squared. And that's really all we really care about for the leading coefficient, is that negative 1. But we'll write the whole thing out. So we get negative 2x and a negative 5x and negative 10. So we'd end up getting negative x squared minus 7x minus 10. And for the denominator, it would just be x squared plus 3x. Okay, so we have the same degree. We're only looking at the leading coefficients at that point, so it's negative 1 over 1, so just the same as what we did that last example. So y equals negative 1. Okay, and then C, that's in standard form. So look at the degrees. The bottom is greater, so that means its vertical asymptote, or sorry, horizontal asymptote would be y equals 0. Okay. Yeah, so again, really we don't have to put it into standard form. We could just look at the leading coefficients. So we've got negative times x would give us negative x squared, and then x times x is the x squared, and you could just come up with it that way too. That might be a little easier. Okay. All right. So let's do the other things. Values of discontinuity. So what would break the equation? What makes the bottom 0? Okay, so here it would be x equals 2. So we'd say we cannot use 2. Okay, the domain would go from negative infinity to 2, and then from 2 to infinity. Vertical asymptotes would be x equals 2. X and y intercepts. So x intercepts, again, is what makes this be 0. So x would have to be 4. So let's write that down. We have x equals 4, so 4, 0. And then the y-intercept, again, we just set x equal to 0. So we'd have negative 0 minus 4 over 0 minus 2. And again, you're welcome to use a calculator to type that in if you'd like. It's not too bad. It'll become 4 over negative 2, which is negative 2. So it would have 0, negative 2. Okay. All right, let's try another one. Finish these ones up. So what makes the bottom 0? Well, either x cannot be 0 or negative 3. The domain, again, would go from negative infinity to the next smallest number would be negative 3, and then negative 3 to 0, and then 0 to infinity. Vertical asymptotes, oh, sorry, I messed that up. That should be not equal to, right? Vertical asymptote is x equals 0 and x equals negative 3. X-intercepts, again, what makes the top 0? Well, either x would have to be negative 2 or x would have to be negative 5. So negative 2 and negative 5. And then the last thing is the y-intercept. Again, we just set everything equal to 0. Again, if you see an x by itself in the bottom, it's going to make the equation, when we put 0 in, it will give us an undefined. So you're welcome to type the whole thing in if you'd like, but if you realize that plugging in a 0, or if like plugging 0 in, which was one of our values of discontinuity, it would give us undefined, or your calculator would tell us it's an error, but we'll write it out. So this would end up giving us negative 10 over 0, again is undefined, and we will call that DNE, does not exist. Okay, last example. So this one, why don't we do the y-intercept first? Okay, so again, when we plug in 0, the x's will be all gone, and we just end up getting y equals negative 12/6 or negative 2. So that's really easy if it's in standard form. I guess we could have done it with these other ones. Okay. So like this example that we drew or wrote down here, if you plug 0 in, again, we only look at the constants. This would be like a 0. I can write that here. This would be our ratio, which is what we have down here, and that's undefined. And then here, again, in standard form, we'd have 4 over negative 2, and that's what we end up getting over here. So if you put it into standard form, it's easy to find that y-intercept. Okay, so let me write that down. Sorry, you're probably getting motion sickness. So 0 comma negative 2. Okay, so let's go back and talk about the excluded values. So here again, we would need to write this in standard form. So we have x minus 12 over, and then we would need to factor. So what could multiply to 6 and add to negative 5? So the hint is that it has to both be positive or both negative. So I think we're going to have to end up doing, maybe I'll write it over here. So multiply to 6 and adds to negative 5. I think it'd be negative 2 and negative 3. So we'd get x minus 2 and x minus 3. So now we can find our excluded values, or our values of discontinuity. So x cannot be 2 or 3. So x cannot be equal to 2 or 3. So the domain would go from negative infinity to 2, 2 to 3, and 3 to infinity. And then the values of, the vertical asymptote is the vertical lines of x equals 2 and x equals 3. Horizontal asymptotes, we already did that. X-intercepts is the last thing. So again, we just say, well, what makes the top 0? Well, x would have to be 12. So we'll just write that as an ordered pair, 12, 0. Okay, so that's pretty much it. I hope that was helpful. Hopefully going over the stuff we did last time will be helpful. But again, let me know if you have any questions, and we'll see you later.